Good morning, good afternoon, or good evening, whatever time you're watching this educational video. Uh, this moment, we will be discussing about the Coulomb's law. I provided also few problems, simple problems that will use the equation of this law. Before that, we will begin with the basics about the scope of this law. But before anything else, we will have the law of charges first. Very basic. When you will have two unlike charges, we have positive and negative, they will definitely attract. And like charges attract, while the like charges, they will repel as the arrows or the vectors of this force that will push these two charges away from each other. So they are uh, repulsive, okay? As well as the two negatives, they will be repelling from each other. Okay, that's the basic. And what makes these charges attracted or unattracted to each other? Why these like charges um, attracted and why these like charges um, unattracted or they repel? It's because of force, of course. There is a force that will repel and attract these charges. And the specific name of this force, you can call it electric force, electrostatic force, or the Coulomb's force. All right, so these are the names that you can use pertaining to the force that will attract or repel charges. Let's say, for example, we have positive and negative charge. Of course, they are attractive in nature. In physics, they will attract. Let's say it's charge 1. Q, lowercase q, that represents the charge, the symbol for charge. And we have charge 2, which is the negative. And of course, we will be practicing how to make this variable here, like f2 comma 1, or yeah, we can read it as force on 2 due to 1. Okay, force on charge 2 due to 1. Okay, we will be knowing this stuff later on. And the arrow is going to the positive because negative attracts the positive. On the other hand, we can say force on 1 due to 2. So it's like the third law of motion. Different direction, but then again, the magnitude or the value is the same. Let's say we have charge 2 a negative and charge 1 negative, so of course they will repel. So if you notice the arrow pulls, or let's say the arrow is pointing away from the negative charge, from the other negative charge, because they are like signs. Like signs repel. Okay, let's say force on 1 due to 2. So 2 will push 1, so that's why the direction is like this, going to the left, or it's negative. Yeah, we will be practicing this one in a little while, okay? The same thing is true to this. Yeah. All right. So this is the person behind the Coulomb's law. It's Charles Augustin de Coulomb. Yeah, that's why the unit of charge is Coulomb itself. This is the unit of charge, or represented by caps lock C. Okay. And credited for his experiment using a torsion balance. Okay. I will not be discussing about how we experimented it, but maybe in other video I can make an explanation about how he did his experiments about the torsion balance. Okay. The findings behind this experiment were the following. We have this equation. Force is directly proportional with the product of these two charges. So just multiply charge 1 and charge 2. Yeah, the more charges you calculated, the higher the force, and the lesser charges, the lesser product, the lesser the force. So it's directly proportional. Electric force, or the Coulomb force between charges, is directly proportional to the product of the two charges. Next finding, we have force is inversely proportional to the square of the radius or distance. Likewise, Coulomb force is directly, or I mean, sorry, it's inversely proportional to the squared of their radius. And if you noticed, if the charges are near, shorter distance will have a greater attraction or repulsion. Okay? Because when we have a shorter distance, it's inversely proportional, so we have greater Coulomb's force. On the other way around, if we have longer distance, very far from each other, the attraction or repulsion will be weaker and weaker, so we have less Coulomb's force. It makes sense, but we need another thing. We want to know the magnitude of repulsion or attraction forces between charges. Yeah, and forces there is specifically called electrostatic or electric Coulomb's force. Then we need a proportionality constant or K to cancel out the other units and to let the unit force be the remaining unit. Okay, so we need the constant K, and I made a video about the proportionality constant or the Coulomb's constant. So you can check that one out. And this Coulomb's constant is very crucial because it will cancel out other units and then let the force be the remaining unit. It makes sense because we need to find the magnitude of forces, and the unit of force is Newton. So that's why we need this K or the Coulomb's constant to come up with the unit Newton. All right. So how to write the interaction or direction between charges. So focus your attention on this because a lot of people or a lot of students might be confused on how to make this a variable. Let's say we have two charges. We have charge one, the positive, and then charge two, the negative, or the proton, charge one, electron, charge two. Then, um, let's say, for example, we have this variable f1 comma 2, or it can be read as force on 1 or force on charge 1 2 to charge 2. And then please take note, charge 1 will feel the force of the neighboring charges. Again, charge 1 will feel the force, and then charge 2 will be the one that pushes and pulls the charge 1. Let's say, for example, charge 1 is our point charge or our reference charge, our focus. So we will try to find out what will charge 2 do to charge 1. Okay? Force on charge 1 will feel the force due to charge 2. Now, what will charge 2 do to charge 1? So negative and positive, attractive. So charge 2 will be the one to push or to pull. So since negative and positive are attractive to each other, so the negative will pull the positive towards uh, Q2. So that's the meaning behind force on charge 1 due to charge 2. So the direction will be to the right. Again, charge 1 will feel the force, and then charge 2 will do something, push or pull. So charge 1 is our point or reference. So we will try to know what will charge 2 do to charge 1. So charge 2 is negative, charge 1 is positive. So charge 2 will be the one to push or pull. And then since they are unlike signs, so charge 2 will pull positive towards it. So the vector of the Coulomb's force will be going to the left. What about if we will change? Let's have force 1 due to charge 2. We're done with that. Charge 1 will feel the force, and then charge 2 will push the force. So force on charge 1, this is charge 1 due to charge 2. So let's try to find out what does charge 2 uh, do to charge 1. So again, they are both like signs. So in physics, they will gonna repel. So charge 2 will what? Charge 2 will push charge 1 because charge 2 will be the one to push or pull, and then charge 1 will feel the force. So charge 2 will push the electron to that direction. That's why force 1 due to 2 is going to the left. This is now force 1 due to 2. Okay? And what about force 2 due to 1? So we will try to reverse now the situation. Charge 2 is our point charge, our reference, our focus. So charge 2 will feel the force. Yeah, charge 2 will feel the force. And then charge 1 will now gonna be the one to push or to pull. So since they are unlike signs, therefore, charge 1 will have to push away charge 2 because they are like signs. So that's why we have a direction going to the right, or it's positive in our sign convention, and we'll have negative if it's to the left. Again and again, when you will write this variable, the first charge you will write will be the one to feel the force. And then 2 will be the one to do something like pushing or pulling, and that will determine the direction. I will explain it one more time. Let's say, for example, we have force 1 to 2, meaning force force 1, force on 1 due to charge 2. So force on 1, this will gonna be our reference. And then what will be charge 2 mechanism towards charge 1, since they are like signs, so charge 2 will have to pull, not to pull, sorry, will have to push charge 1. So that's why we have this direction here going to the left. Okay, same is true with force on 2 due to 1. So 2 will gonna be our point charge, and then 1 will gonna be the one, charge 1 will be the one who will push or pull, since they are like signs, so therefore charge 1 will push charge 2. So the direction will be this way. Okay? I'm very sorry because it might confuse you. It might look like they are attractive to each other, but then again, charge 1 will have to push charge 2. That's why we have this direction. Okay. So, let's continue. How to write the same thing, how to write um, the interaction between charges. Let's say, for example, charge 1 is positive and then charge 2 is negative. Force on 1 due to charge 2. So this will gonna be our reference, our focus, and then charge 2 will do something to charge 1. It will determine the direction of the Coulomb's force. So charge 2 is negative, charge 1 is positive, they are attractive. So charge 2 will have to um, pull positive towards it. So the direction will be going to the right. Here it goes, going to the right. The direction is going to the right. What about if we have force on 2 due to charge 1? I will just erase this one for a while. Okay. Force 2 is force on 2 or charge 2 will gonna be our focus here, our reference point. So let's try to find out what does charge 1 do to charge 2. Positive will attract negative, so charge 1 will have to pull charge 2. Okay? So that's why the direction will be going to the left, because charge 1 will pull charge 2 towards it, positive. So that's why you can see arrows are attracting or pointing towards each other. It signifies attraction. Okay, I hope you got the point on how to jot it down. Force on 2 due to charge 1, or force on charge 1 due to charge 2, and vice versa. It's just like third law of Newton. It's the interaction, meaning same magnitude, the same values, but opposite in direction. One is going to the right, the other is going to the left. So it's like the interaction. or the third law of motion. Okay, now let's figure out the direction of the interaction of charges if charge 3 is our reference point. So we have three charges. Uh, Depends upon how they labeled it, but in this case, this is charge 1, this is charge 3, and this is charge 2. And according to our statement here, charge 3 is our reference point, our focus. So let's try to find out what's the influence of the other charges nearby. Okay, so we have two charges there interacting with charge 3. So let's begin with force on 3 because we used force on charge 3. We wrote it first because charge 3 is our point or our point charge or reference or our focus. So force on charge 3 due to 1. So let's try to make uh, to study the interaction between charge 3 and charge 1. Okay, charge 3 will feel the force, and then charge 1 will have to pull or push. They are both unlike signs, so charge 1 will have to push the proton this way. Okay, sorry, I'm using the wrong word. It's pull the proton towards charge 1. Okay, so the direction will be going to that direction. Okay, since Q3 is our point charge, we will be putting the arrows uh, along or in or near Q3 or charge 3. That's force on 3, charge 3 due to charge 1. What about the other charge? There is an interaction between these two as well. So the direction, by the way, is you can write left or negative. Okay, same thing. Force on 3, since 3 is our point charge, force on charge 3 due to charge 2. So force charge 3 is our point charge. So let's try to find out what does charge 2 do to charge 3. They are definitely unlike charges. So charge 2 will have to pull Q3 positive towards it negative. So the direction will be going to the right. You can just say, you can just write right or positive. Okay. What about our point charge will be 2? I will give you enough time to do it. Okay. So this will be our point charge. So what will be the interaction of charge 2 to 3 and charge 2 to 1? Remember how to write the variable if you want to describe the directions of the following interactions. Okay, take your time. Now the answer is this. Force on charge 2. Charge 2 is our point charge. So we wrote charge 2 first, and then the interaction between charge 2 and 3. Positive and negative, they will attract. So what will gonna happen there? Charge 2 will feel the force, and then charge 3 will do the pull or push. Okay. So since positive will attract negative, so it will gonna pull negative towards it. So the direction is going to the left or a negative sign. Now, what about force on 2 due to this charge here? Charge 1. Uh, Q2, charge 2 will feel the force of the attraction or yeah, repulsion because they are in the same charges. So in this case, charge 1 will have to push charge 2 away. So that's why we have this direction here. Going to the right are positive. I hope it makes sense. Okay, so I guess that's it for our video. And in my next video, I will be presenting some problems, word problems related to Coulomb's law. Thank you so much. And yeah, you can like, share, or subscribe this video if it helps you. Thank you so much and have a great moment. Bye for now.